All right, so chapter 2, lesson 5, we're going to write and solve inequalities, which is related to what we've been doing, but instead of an equal sign, we're going to use an inequality symbol. So let's go through these. Represent each of the following as an algebraic inequality. So x is at most 30. So x could be 29, 28, 27, 26, all the numbers less than 30, but x could also be equal to 30. So that means x is less than or equal to 30. And we can put any number in for x that's less than 30 and it would work. Any number that's equal to 30, which is just 30, would also work. So x is less than or equal to 30. Our second one, the sum of 5x and 2x. So that means 5x plus 2x is at least 14, which means at least could be 15, 16, 17, 18, but it could also just be 14. So 5x plus 2x is greater than or equal to 14, and we could simplify that to be 7x is greater than or equal to 14. Our third one here, the product of x and y. Okay, so x times y is less than or equal to, well, that's simple. They tell us right away, less than or equal to, and the number 4. Okay, that's all we got to do. Number 4, 5 less than a number, y, is under 20. So it's a little bit of a strange phrasing, but that just means it's less than, not equal to. So the number y, 5 less than that, is less than 20. So those are going to be the way that we rewrite these words into expressions and inequalities. So using that idea, remember you can pause this at any time to take notes and unpause and continue watching. Using this idea, let's answer this first question here. The cost of a gallon of orange juice is $3.50. What's the maximum number of containers you can buy for $15? So we want to say, let x equal the number of containers. And now the thing about inequalities is that the solution to our inequality may not be our answer. It may be multiple answers. So we know that each gallon is $3.50 and each number of containers is x, and so it's less than or equal to $15. You could spend $15, you could spend less than that, but if you only have 15, you could never spend more. So let's find x. We're going to divide both sides by 3.5. I guess 3.50. So then x is less than or equal to 15 divided by 3.5, 4.2857. Okay, so that's our solution to the inequality. So any number less than that. Now, you couldn't walk into a store and buy 4.2857 containers of orange juice, so the maximum number that we can buy is going to be the largest integer, or the largest whole number that we can use here. So 4 containers is going to be our answer, because 4 is the largest number of containers we can buy that will also be less than $15. Let's look at another example. Pet Supplies makes a profit of $5.50 per bag on its line of natural dog food. If the store wants to make a profit of no less than $5,225, how many bags of dog food does it need to sell? So let x equal number of bags. Remember, you can pause this and try it on your own if you want. We know it's no less than, which means greater than or equal to, because no less than means it can be this number, it could never be less than. It could be greater, it could be equal, but it could never be less than. We know it's $5.50 a bag, and there are x bags. So to solve this, we're going to do what we always do. We're going to divide both sides by 550, and we're going to get that x is greater than or equal to 950. So how many bags of dog food does it need to sell? So we could say a minimum of 950 bags. And we know the word minimum works here because it has to be greater than or equal to. If it's equal to, that's fine. If it's greater than, that's even better. But 950 is the minimum number. All right, let's try another one. A taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend, how far could she travel? All right, so it's $1.75 no matter what, plus 65 cents for every mile. So let's let x equal number of miles. And then it's at most $10, which means she can only spend less than or equal to $10. So to solve this, we subtract 175 from both sides. We get 0.65x is less than or equal to $8.25. We divide 825 by 0.65, and we get that x is less than or equal to 12.69230, etc., etc. So if she's going to travel only whole miles, that means she could travel at most 12 miles. She could travel 11, she could travel 10 or 9 or 8, anything like that, but she can't travel more than 12. So that's how we're going to look at this. Okay, so that's how we're going to use inequalities. They're very similar to equations, but we get more than one potential answer. And I will see you guys tomorrow.